Hello, dear aspirant. A very warm welcome to the discussion for CSAT examination. And today's topic is progressions. It has been seen that of late questions have been asked in the CSAT examination on the topic progressions. So let's have a look at the basic concepts and the methodology to be used to solve such questions. All right, first of all, let us know the meaning of progression. Progression, if we take the literal meaning of this word, it would mean to progress in ascending order. It could be in descending order as well. Now, progression is a sequence in which terms increase or decrease through a constant difference or a multiplier. Now, the types of progressions, we have arithmetic progression, geometric progression, and harmonic progression. Now, let's have a look at the basics for arithmetic progression. Now, an arithmetic progression is a sequence in which terms increase or decrease by a constant number, which is called the common difference. So let us say that we have an arithmetic progression which goes like this. Now here the difference between 5 and 2 is 3, between 8 and 5 is 3, between 11 and 8 is 3, between 14 and 11 is 3, and this is the common difference, usually denoted by D. Now 2 here happens to be the first term, which is denoted by A. So an arithmetic progression usually is represented as A, then A plus D, that is a common difference, then A plus 2D, that is twice the common difference, A plus 3D, and so on, till the nth term, and nth term here is represented by A plus n minus 1D, where A happens to be the first term, D is the common difference, and n is the number of terms which are there in the progression. So this is a very basic formula which is used while solving questions based on progressions. Now, as you see, the sequence 2, 6, 10, 14, 18, and 22 is an arithmetic progression. Well, 2 and 6, the difference is 4. 6 and 10, the difference is 4. 10 and 14, difference is 4. 14, 18, 18, 20. Everywhere, the difference is 4. So the common difference here is 4. And the first term, that is A, is 2. Now, even 2, 5 by 2, 3, 7 by 2, and 4 is an arithmetic progression. So the first term here is 2 and the common difference is half, because 5 by 2 can be written as 2.5. So the difference from 2 to 2.5 is half, then 2.5 to 3 is half, then 7 by 2 can be written as 3.5. So 3 and 3.5 difference is half, and again 3.5 to 4, the difference is half. So everywhere you find that the difference is common, the same, and that is half in this case. So how do you find out this common difference? Well, common difference D is second term minus first term. That is, in this case, 5 by 2 minus 2. Third term minus second term. That is, in this case, 3 minus 5 by 2. And fourth term minus third term. That is, in this case, 7 by 2 minus 3, and so on. Now, the terms of an AP can be written as A plus D, A plus 2D, A plus 3D, up to A plus n minus 1D, which is helpful in finding out the nth term. And this I can rewrite as shown in this table. These are the terms A, so this happens to be the first term. Adding D to A, we get A plus D. Adding another D to the previous A plus D, it becomes A plus 2D. Adding another D to the previous A plus 2D, becomes A plus 3D, and so on. So adding D n times would give us A plus n minus 1D. Once again, please remember, this represents the nth term in an arithmetic progression. So the general term of an arithmetic progression is given by Tn equals A plus n minus 1D. Let's have a look at the questions here. Find the 20th term of the AP, 20, 15, 10, and 5. Now, in the given AP, we know that the value of A is 20. That is, the first term here is 20. Difference will be 15 minus 20, that is minus 5. Even 10 minus 15 will be minus 5. 5 minus 10 will also give us minus 5. So having found the common difference, we have to find out the 20th term using the formula Tn equals a plus n minus 1d. The value of n here becomes 20. The first term also is 20. So this is a, this is plus, this is n, that is 20 minus 1 into the common difference, that is minus 5 here. So 20 minus 1, we have 19. So 20 plus 19 into minus 5, which works out to be 19 into 5 is 95. So hence, the 20th term here has to be minus 75. Now find the nth term and the 20th term of the arithmetic progression 3, 9, 15, 21. Now 9 minus 3 is 6. 15 minus 9 is again 6. 21 minus 15 is again 6. So A here is 3 and D here is 6. So hence Tn equals a plus n minus 1d. Finding out the nth term, a here is 3, n minus 1 into common difference here is 6. So this gives us 3 plus 6n minus 6, which amounts to 6n minus 3. That is the nth term. Now to find out the 20th term, we can directly substitute the value of n here as 20. So this becomes 6 into 20 minus 3, which is 117. Now the first term of an AP is minus 1. So the value of A is given to us and the common difference is minus 3. So this is D, which is equal to minus 3. So find the 12th term of the AP. So A here is minus 1, D here is minus 3. So using the general expression for finding the nth term, we shall find the 12th term as A is minus 1, N is 12 and D is minus 3. So we just need to substitute these values in place of these variables. So hence this becomes minus 1 plus 12 minus 1 is 11 into minus 3. So minus 1 minus 33, which gives us minus 34 as the answer. Now which term of the AP 10, 8, 6, 4 and so on is minus 28? Now here the value of A is 10, that is the first term. Then 8 minus 10 is minus 2. 6 minus 8 is minus 2. 4 minus 6 is minus 2. So the value of D here happens to be minus 2. And also the nth term here is minus 28 and we need to find out what is the value of n, or let us say which term is minus 28 in the given AP. So using the general formula, we know that the value of Tn here is minus 28. A, the first term, is 10. N is unknown, we have to find that out, and D here is minus 2. Now this would mean minus 28 equals 10 minus 2n plus 2. Now this can be rewritten as minus 28 minus 12 equals minus 2n. So 2n here becomes 40. By that we get the value of n here as 20. So minus 28 is the 20th term in the given AP. Now the 8th term of an AP is 17 and 19th term is 39. So find the 20th term. So now we know that the 8th term is A plus 7D. What is 7 here? That is nothing but n minus 1, which is 8 minus 1. And that is equal to 17. So this happens to be our first equation. And T19, that is the 19th term, is A plus 18D, which is given to us as 39 in the question. So on subtracting 1 from 2, we get A plus 18D equals 39 and A plus 7D equals 17. So 18 minus 7 shall be 11. 11D equals 22. So D here equals 2. So the common difference we have found out works out to be 2. Now substituting the value of D in equation 1, we get A plus 7D equals 17. So A plus 7 into 2 equals 17. So A plus 14 is 17. So we know that A is 17 minus 14, which is equal to 3. So we have found out the first term. Now the first term, A is known to us, that is 3. Common difference is also known to us as 2. So the 20th term, that is what the question is asking us to find out. So T20 shall be equal to A plus 19D. Substituting the values, A is 3 and D is 2 here, shall become 3 plus 38, which is nothing but equal to 41. So for the given series, the 20th term will be 41. Now Sachin saves rupees 1000 in the first week of a year and then increases his savings by rupees 350 every week. Now in which week of the year will his savings be rupees 4150? Now A happens to be 1000 here because Sachin saves rupees 1000 in the first week. So this becomes A. And he's increasing his savings by rupees 350 every week. So this must be the value of D. So we need to find out the week in which his savings amount to 4150. So that is the value of N. So using the general expression, we know Tn is 4150, A is 1000, N we have to find out anyhow, and D is already given to us as 350. So from this we get 3150 as 1000 gets deducted from 4150 and is divided by 350 to give us N minus 1. So 350 into 9 is 3150, which is equal to N minus 1, by the virtue of which we get the value of N as 10. So it is in the 10th week of the year that Sachin's savings will be 4150. Now if in an AP the 20th term is 16 more than the 12th term, then find out the common difference of the AP. So the 20th term here is 16 more than the 12th term. That is what is given to us here. Using the general expression, we get that 20th term, which can be written as A plus 19D, that equals the 12th term, that is A plus 11D plus 16. So as it is, A and A cancels. 19D minus 11D is 8D, which equals 16. So D here becomes 16 by 8, that is equal to 2. So we obtain the value of D here as 2, which is the common difference for the given AP. Now for what value of N, the nth term of AP 51, 53, 55, 57, where the difference here, as you can see, is 2, these are odd numbers, is equal to the nth term of the AP 15, 20, 25, 30, where the difference here is 5. So the idea here is that for this AP and for this AP, the nth term should be the same. It should be equal. So we have to find out the value of N. So the nth term of the first AP shall be equal to the nth term of the second AP. Using the general formula, in the first AP, value of A is 51 plus N minus 1, and the difference here is 2. So this is A plus N minus 1 into 2. And this, for the second AP, the first term is 15 plus N minus 1 into the common difference, that is 5. Now solving this here, we get 51 plus 2n minus 2 and 15 plus 5n minus 5. 51 minus 2 is 49. 15 minus 5 is 10. So we carry that 10 to the left hand side to get 49 minus 10. And 5n minus 2n, which we bring to the right hand side, shall give us 3n, which is equal to 39. So hence the value of n here is 13. So the 13th terms of both the APs will be equal. Now the sum of n terms of an arithmetic progression, it is given by, sometimes questions have been asked on finding out the sum of the terms for a given arithmetic progression. So there we have a formula, that is Sn equals n by 2, 2a plus n minus 1d. Now when we write this as n by 2, 2a plus n minus 1d, we shall separate the two a's here and rewrite this. Now this we know is nothing but it is the nth term, the last term. So a plus l. So this is another expression depending on whether the last term is given or not. So whenever last term and first term both are given in an AP and the number of terms are known, we can easily find out the sum of the terms in the AP. So L is the last term, as can be seen here. So let's have a look at the question on this concept. Find the sum of the first 20 terms of the AP 2, -1, -4, -7. Now -1 minus 2 is -3. -4 minus -1 is again -3. -7 minus -4, that is -7 plus 4, shall again be -3. So A here is 2, D here is -3, that is what is our concern, and N is 20. So all these things given to us, let us make use of the formula for finding out the sum of n terms. So n is 20, so 20 by 2, A is 2, and D here is -3, and as it is 20, so just by substitution, we get 20 by 2 here as 10, 2 into 2 is 4, and 20 minus 1 is 19, into -3 is -57. So this shall become 10 into -53, which works out to be -530. That would be the sum of all the terms in the given AP. Now find the sum of the series 5, 10, 15, 20 and so on till 125. Now here it is known that the value of A is 5 and also the last term is given to us, that is 125. So only thing that we need to now find out is the nth term, because the number of terms needs to be known. So 125 is the last term, and what is its order or sequence as the last term? So A given, B we can find out, that is 10 minus 5 is 5, 15 minus 10 is again 5, and the last term is 125. So using the general expression Tn equals A plus n minus 1D, the last term is known as 125, the first term here, and obviously we need to determine, and D is known to us as 5. So what we get here is 125 equals 5 plus 5n minus 5, wherein minus 5n plus 5 cancels. So what we get here is 5n equals 125, from which we get the value of n as 25. Now to find out the sum, we know Sn equals n by 2 A plus L. That is, the sum of these 25 terms shall be 25 by 2 into 5, which is the first term, and last term here is 125. So this shall become 25 by 2 into 130. This goes by 65. So this becomes 25 into 5 is 125, 12 remaining. Gets carried over, 25 into 6 is 150, plus 12, that is 162. So 1625 is the sum of all the terms in the given arithmetic progression. Now the sum of n terms of the AP 24, 21, 18 and so on amounts to 78. Now find out the value of n. So A is known here, and also 21 minus 24 is -3, 18 minus 21 is -3. So even the value of D is known. So A is 24 and D here is -3. And Sn is given to us as 78, the sum of n terms. So finding out the value of n, we shall use here the general expression or formula for finding out the sum of n natural numbers. Because A and D are mentioned and last term is not given to us, so we will make use of this formula. Substituting the values, Sn, that is the sum of n terms, is given as 78. N by 2, n here is unknown, so we will keep it as it is. Then twice of A, that is the first term, which is 24. N again remains the same, and D here, the common difference is -3. So 2 into 24 is 48. And n minus 1 into -3 shall become 3 minus 3n. Resolving this, 2 goes to the left hand side, 78 into 2 is 156. N remains here on the right hand side. 48 plus 3 is 51 minus 3n. So this shall become 51n minus 3n square. So we can form an equation here by taking this expression on the left hand side. So we get 3n square minus 51n plus 156. Now each of these numbers, 3, 51 and 156, is divisible by 3. So we will reduce this equation by dividing it by 3 to get the reduced form as n square minus 17n plus 52. Factorizing this, We know minus 17 is minus 4 minus 13, and 13 is 52. So the value of n here will work out to be either 4 or 13. Arithmetic mean or average. If three numbers are in arithmetic progression, the middle number is called the arithmetic mean of the other two terms. In fact, if we have odd number of numbers and these numbers are arranged in ascending or descending order, then in that case, the middle number is going to be the average mean, the arithmetic mean, or the average of the given AP. Now, if A, B, C are in arithmetic progression, then B is A plus C by 2. Now, you can take it like this as well, where B is the arithmetic mean, like 30, 40, 50. 30 plus 50 is 80 divided by 2. Or else directly you can take this number, the middle number here, as the arithmetic mean. If n terms A1, A2, A3 up to AN are in AP, then the arithmetic mean of these n terms will be given by the sum of these terms divided by the number of terms. So that is what we have learned in average as well, which is nothing but sum of quantities divided by the number of quantities. Now, what will be the arithmetic mean of the first 10 natural numbers? Well, sum of these numbers divided by 10. So 10 into 11 by 2 into 10, that is 5.5. Also, this can be taken as sigma n by n. Sigma n we know is n into n plus 1 by 2, then divided by n. N gets cancelled here in the numerator and denominator. It becomes n plus 1 by 2. And the value of n here is 10. So it shall be 11 by 2, which is 5.5. So this is another way in which you can solve this. If the same quantity is added or multiplied to each term of an AP, then the resulting series is also an AP. Like if 2 is added to each term of the AP, 10, 15, 20, 25 up to 50, then the resulting series, that is 12, 17, 22, 27 and 52, will also be in AP, because the common difference in each case has increased by 2. Because even after adding 2 to each of the numbers or each of the terms of this AP, the common difference still remains the same. Here 10 and 15, the difference is 5. 15, 20, the difference is 5. So the common difference here is 5. In the second AP wherein we had added 2 to each of the terms, 12 and 17, the difference is 5. 17 and 22, the difference is 5, and so on. So the common difference remains the same. So it still results in another AP. Now, if 2 is multiplied to each term of the AP 10, 15, 20, 25 and so on till 50, then also the resulting AP, that is 20, 30, 40, 50 and 100, is still an arithmetic progression. However, the common difference would become different in each case. Here the common difference is 5, here the common difference is 10. That is double the previous common difference. Because we are multiplying each of the terms with 2, so the common difference also gets multiplied with 2. Now, if three terms are in AP, now they can be written as A minus D, A and A plus D. So D less and D more from A, and A here happens to be the arithmetic mean, as is given here. If there are 4 terms, then they can be taken as A minus D, A minus 3D, A plus D, A plus 3D, AM, or arithmetic mean still remains to be A. In fact, for 4 terms, if we need to find out the arithmetic mean, we can add the second and third number and divide it by 2. So let us say that we have these 4 numbers A, B, C, D in an arithmetic progression. Then the arithmetic mean shall be B plus C by 2. That is a sum of the middle 2 numbers divided by 2, or the average of the middle 2 numbers. If there are 5 terms, well, they can be written as A, A minus D, A minus 2D, A plus D, A plus 2D. And once again, the arithmetic mean will be the middle number, that is A. Now find 3 numbers in AP whose sum is 36 and product is 1620. So let the numbers be A minus D, A and A plus D. So Their sum is 36. So minus d and plus d cancels. So 3a becomes equal to 36, which means a is 12. Now their product is a minus d into a plus d, which is a square minus d square into a, and that works out to be 1620. But then we have the value for a here. We have already found it out to be 12. So substituting the value of a, we get 12 minus d, 12 and 12 plus d, and that is equal to 1620. So 12 minus d and 12 plus d, when you multiply, you get 144 minus d square by the formula, that is a plus b into a minus b equals a square minus b square. And this 12 here goes towards the right hand side and becomes the denominator below 1620. So 144 minus d square, 1620 by 12 works out to be 135. We get an equation that is d square minus 9 equals 0, because 144 minus 135 is 9. So the value of d here is plus or minus 3. So either the common difference is positive 3 or a negative 3. But either ways, the numbers are going to be 9, 12, 15 or 15, 12, 9 when you substitute the value of d in these three numbers. As it is, we know that the value of a here is 12. So 12 minus 3 and 12 plus 3 shall give us 9, 12 and 15, or 12 plus 3 and 12 minus 3 here shall still give us 15, 12 and 9 as the AP. Geometric progression. Now, a geometric progression is a sequence in which terms increase or decrease by a constant ratio called the common ratio. In case of arithmetic progression, the increase or decrease happened because of a common difference. Now in geometric progression, the increase or decrease will happen due to a common ratio. So let us have a look at the sequence 1, 3, 9, 27, 81. A careful look will suggest that 1 into 3 is 3, 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. So the first term is 1 and the common ratio is 3, which is represented by R. Now in this sequence, as we can see, the first term is 1 and the common ratio is 1 by 3, because 1 into 1 by 3 is 1 by 3 and 1 by 3 into 1 by 3 is 1 by 9, which again multiplied by 1 by 3 gives us 1 by 27 and so on. Now a geometric progression is represented by AR square, and the nth term is represented by AR raised to n minus 1. So the nth term in case of a geometric progression shall be represented by AR raised to n minus 1, where A is the first term, R is the common ratio, and n is number of terms in the progression. So this is a journal term. Then let's have a look at some questions based on geometric progression. Find the nth term and 8th term of the GP, minus 3, 6, minus 12, 24, minus 48, and so on. So clearly, minus 3 into minus 2 is 6. 6 into minus 2 is minus 12. Minus 12 into minus 2 is 24, and so on. So A here is minus 3, the first term, and the common ratio here is minus 2. So finding out the nth term and the 8th term, substituting in the formula for the general term, A, that is minus 3, into R, that is minus 2 raised to n minus 1. So the 8th term here is given by minus 3 into minus 2 raised to 8 minus 1, because the value of n here is 8. So minus 3 into minus 2 raised to 7. Now you should remember the values of exponents of 2, where the exponents or the powers vary from 1 to 10. So 2 power 6 is 64, that you must remember. So 2 power 7 anyhow is double of this, that is 128, in case you don't remember what is 2 power 7 separately. So 128 into 3 is what we are looking at. So 8 3s are 24, 3 2s are 6, becomes 8, and 3 1s are 3. So we get a 384 here as the 8th term. And this is the nth term. Now, given below are certain series, identify whether a given series is an AP or a GP. Now, 1.3, 3, 4.7, 6.4, 8.1. Now, what is it? An arithmetic progression or a geometric progression, or neither of these? Well, let's take the difference. 3 and 1.3, the difference is 1.7. 4.7 and 3, the difference is 1.7. 6.4 and 4.7, the difference is 1.7. 8.1 and 6.4, the difference is 1.7. So here, the difference is 1.7, the common difference. So this happens to be an arithmetic progression. Now look at this one. 4 into 3 is 12, into 3 is 36, into 3 is 108. So here we have a common ratio, that is 3, a multiplier. So this series is a geometric progression. 3, then 0.3, then 0.33, then 0.333. Now in this series, 3 by 0.3 is 10. Then 0.3 by 0.33 equals 10 by 11. Then 0.33 by 0.333 shall become 110 by 111. So it does not make any sense. There is no common ratio or a common difference. So this is neither an AP nor a GP. Now 1 by 3, 0, minus 1 by 3, minus 2 by 3. Quite simple. 1 by 3 minus 1 by 3 is 0. Minus 1 by 3 is minus 1 by 3. Minus 1 by 3 is minus 2 by 3, and so on. So this is definitely an AP which has a common difference of minus 1 by 3. 2 by 3, 4 by 9, 8 by 27, and so on. So this is quite clear. 2 by 3 into 2 by 3 is 4 by 9. Into 2 by 3 is 8 by 27. Into 2 by 3 is 16 by 81, and so on. So here we have a common ratio, and that is 2 by 3. So hence this is a geometric progression. 4 by 3, then 4, then 4 by 3, then 4. At alternate places, 4 by 3 and 4 are written. So anyhow, for sure, this is neither an AP nor a GP. All right, the nth term of a GP is 3 by 2 raised to n. So this is 3 by 2 raised to n. Now find the ratio of the fifth term to the 10th term. So the value of nth term here is given to us as 3 by 2 raised to n. The fifth term here shall be 3 by 2 raised to 5. And the 10th term here is 3 by 2 raised to 10. 2 raised to 10. So the ratio of these two terms, that is T5 is to T10, shall be 3 by 2 raised to 5 is to 3 by 2 raised to 10. As it is, we have substituted these values. So let us say this is 3 by 2 raised to 5 is to 3 by 2 raised to 10. So these two values cancel. That is 3 in the numerator. And then even the exponents cancel here, making it 1 is to 1 by 2 raised to 5, or 2 raised to 5 is to 1. Now we know that 2 raised to 5 is 32. So the required ratio is 32 is to 1. Now determine the ninth term of GP whose eighth term is 192 and common ratio is 2. So R is given as 2 and the eighth term, that is T8, is given, which is AR raised to 7, and its value is 192. So substituting number 2 in place of R, we get A into 2 raised to 7, that is equal to 192. So 2 raised to 7 we know is 128. So 192 by 128, that is 3 by 2, is the first term. Now as we know the first term, we shall use the formula for finding out the general term, that is Tn equals AR raised to n minus 1. So let's find out T9 because we have to find out the ninth term. So that is AR8. Now the value of first term is 3 by 2. And this is 2 which is raised to 8. So this is 3 by 2 into 2 raised to 8. This cancels. and the power becomes 7 here. So 3 into 2 power 7, that is nothing but 384. So that is the ninth term of this series. Now the first term of a GP is 50 and the fourth term is 1350. So determine the sixth term. Now the value for A, or how much is the common ratio. Now we know that the first term of the GP is 50. So A here is 50. And the fourth term is 1350. That is T4 is 1350, which is 50 into R cube. So from this we know 1350 by 50 equals R cube, which is equal to 5 2s and 7s. So R cube is 27. So the value of R here becomes 3, as 27 is cube of 3. We have to determine the sixth term, that is T6 equals AR raised to 5. So that is 50 into 3 raised to 5. We know that 3 raised to 4 is 81. So 3 raised to 5 is 243. So the value of the sixth term becomes 50 into 243. That is 12,150. Now the sum to n terms of a geometric progression is given by Sn equals A into 1 minus R raised to n divided by 1 minus R. So this is how it appears. Now obviously we do not want a negative value here. So this formula shall be for the values of R which is less than 1, and for the values of R which are greater than 1, you can just reverse the order in which Rn and 1 are written in the numerator and in the denominator. Now let's see where this formula gets used. Now in a certain colony of cancerous cells, each cell divides into 2 every minute. How many cells will be produced from a single cell if the rate of division continues for 12 minutes? So the total number of cells here are 2 raised to 1, 2 raised to 2, 2 raised to 3 and so on till 2 raised to 12. So in 1 minute, 2 cells. In the second minute, 2 into 2, that is 4. In the third minute, 4 into 2, that is 8 and so on. So here the value of A is 2. The R is also 2. And we know that Sn equals A into R raised to n minus 1 by R minus 1 here. R is greater than 1. So using this formula, we get A into R raised to n minus 1, that is 2 raised to 12 minus 1. The value of n here is 12 because the division continues for 12 minutes. And this is divided by R minus 1, that is 2 minus 1. Now 2 raised to 10 is 1024, 2 raised to 11 is 2048, and 2 raised to 12 is 4096. So this shall become 2 into 4096 minus 1, that is 4095, divided by 2 minus 1, that is 1 only. So the double of 4095 shall be 8190, as we can see here. So the total number of cells, if the division continues for 12 minutes, will be 8190. That's quite a lot. Now, if 3 numbers are in geometric progression, the middle number is called the geometric mean of the other 2 terms. 10, 100 and 1000, like into 10, into 10. And that can be found out using the formula B is equal to square root of AC. So here A is 10, C is 1000. We take the square root, we get 100. Now for a decreasing geometric progression, please remember the sum to infinite number of terms is S infinity equals A by 1 minus R. So please remember this, S infinity is equal to A by 1 minus R. A is the first term and R has to be less than 1. And let's see, where do we use this formula? So find the sum to infinity for the GP. Minus 1 by 4, 1 by 16, minus 1 by 64. So clearly, this is minus 1 by 4 into minus 1 by 4. That is 1 by 16. 1 by 16 into minus 1 by 4. is minus 1 by 64 and so on. So the value of r here is minus 1 by 4. A is known to us again as minus 1 by 4. Now r here is less than 1 anyhow. So we know that sum to infinity of all the terms, sum to infinity for this GP shall be a by 1 minus r, which is minus 1 by 4 by 1 minus 1 by 4. This shall become minus 1 by 4 by 1 plus 1 by 4 minus 1 by 4 by 5 by 4. 4 cancels. So we should get minus 1 by 5 here as the answer. If every term of a GP is multiplied by a fixed real number, then the resulting series is also a GP. And if every term of a GP is raised to the same power, then also the resulting series is a GP. Now also the reciprocals of the terms of a GP are also in a GP. Now we shall look at the examples for each of these. By that I mean that if there is a GP that is 2, 4, 8, 16, 32 and so on, then even 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, the reciprocals of each of these terms is also a GP. Here each time 2 is getting multiplied, and here each time 1 by 2 is getting multiplied. Now the three numbers in a GP can be written as a by r, a and ar, like 2 by 3, 2 and 6. If there are four numbers, then they can be written as a by r cube, a by r, ar and ar cube. That is 2 by 27, 2 by 3, 6 and 54. Thus multiplying with 9 each time. If there are five numbers in a GP, they can be taken as ar square, a by r, ar square. Quite similar to what we observed while taking the representation of various terms in an arithmetic progression. So 1 by 4, 1 by 2, 1, 2, 4. So multiplying with 2 every time. Now harmonic progression, the third type of progression. If the reciprocals of the terms of a series form an arithmetic progression, then the series is called harmonic progression. So harmonic progression is nothing but it is the reciprocal of an arithmetic progression. Now there is a sequence 4 by 3, 3 by 2, 12 by 7. It is a harmonic progression as 3 by 4, 2 by 3 and 7 by 12 is an arithmetic progression. Now let's have a look at this question. Which of the following series is the harmonic progression of the given series? So 1 by 2, 1, 3 by 2, 2, 5 by 2. We just have to take the reciprocals of each of the terms here. So choices are given to us. So 1 by 2 becomes 2, 2 by 1 is 2, 1 stays as 1, 3 by 2 becomes 2 by 3, 2 becomes 1 by 2, and 5 by 2 becomes 2 by 5. So if we look at this series, it's given to us in choice B. That should be the harmonic progression for the given arithmetic progression. Now that brings us to the end of this session. Please make sure that you revise and practice questions based on this topic. We will meet again in the next discussion. Till then, don't lose your grip on the goal that you have set for yourself. So keep working hard, stay fit, and stay safe. Thank you.